Hi, this is Kenneth Rosever. Welcome to another episode of Pass This Class, Please, for the Love of God. This is to help you on your Unit D test. This is number 5. I'm going to review this concept with you. It says solve the equation algebraically and state answers in simplest form in set notation. Remember to show all work. And we're given a quadratic equation here. There are 4 ways to solve a quadratic equation. You can do, well, 5 I guess if you used guess and check. Not that you'd get the answer here by guess and check, but the 4 regular ways of solving a quadratic equation are quadratic formula, factoring, completing the square, and graphing. And since it says algebraically, graphing is off the table. So we're going to have to do this by hand. So since most of you are probably interested in going about it with the quadratic formula, I'll begin by demonstrating that method. If you have a formula ax squared plus bx plus c equals 0, then you're allowed to use this formula to find the solutions for x. This formula is a consequence of the process of completing the square. If you complete the square on this thing, you'll get this formula. So in here, what are a, b, and c? Well, the truth of the matter is, I don't know yet, because I haven't met the condition yet to use a quadratic formula. The quadratic formula requires this is the antecedent. If you have something in this form, then you can solve it using the quadratic formula. But we haven't made it into that form yet. We have to set it equal to 0. So we need to reconfigure the equation so that one of the sides says equals 0. And the easiest way to do that is to move the negative 6 to the other side, making it a positive 6. Now normally, I'm a factorer. I'm good at factoring. I would check, is there a way to factor this? So I would go, are there 2 factors of 1 times 6? Are there 2 factors of positive 6 that add up to negative 3? And unfortunately the answer is no. So we are not going to be able to factor this by hand. We could complete the square on it, and I'll do that next. But for now, I will just point out that a is 1, b is negative 3, c is 6, and the whole quadratic equation is equal to 0, so we can use the quadratic formula. So x equals the opposite of b. b is negative 3, so the opposite of b is positive 3, plus or minus the square root of b squared, now let me put that in parentheses, minus 4 times 1 times 6 all over 2 times 1. Well, that gives me this. And 9 minus 24, ooh, this is going to come out to a complex answer, because 9 minus 24 is negative 15, and we're going to divide that by 2. So the 2 answers we will have in set notation will be 3 over 2 plus the square root of 15 over 2i, comma, 3 over 2 minus the square root of 15 over 2i. And that will be our solution set. I'm skipping a step here, but you know that this is the numerator, right? If you pull the negative 1 out, the square root of negative 1 is I. And then if you distribute the division, you get that. And I'm just putting the I afterwards, because we like to write these in the form A plus B I. Okay. So that's one way of doing it. That's the quadratic formula. So if you like that, you can stop the video now. But if you want to see a demonstration of how to do it by completing the square, or how to do it using my alternative to completing the square, you can keep watching. So if you're going to complete the square using the traditional method, then you're actually ready to go just based on what you have here. All you have to do is figure out what needs to go here and needs to be added to the other side so that this thing, this trinomial on the left, will factor into a perfect square polynomial, or will factor into a square of a binomial, or binomial squared rather. So the answer to that is, what you need to add is always the square of half the middle term, which is this right here. The reason I can jump right in and do that, though, is because there's no leading coefficient here. If there was a leading coefficient, then the first thing I would do in this process is I would divide out that leading coefficient. And then I would look at the coefficient of the x term, and I would divide that sucker in half and then square it. And that would be what I would add to both sides. So if I take -3 and I divide it by 2 and I square that, that is positive 9/4. And that's what I need to add to both sides. So let me erase these little blanks because I know what goes there now. It's positive 9/4 and 9/4 over here. When I do that, now this is a perfect square trinomial, and it'll factor into this. You'll notice that this right here is half of that. And you write, that's it. You put a parentheses around it and a square, and there you go. It's pretty straightforward. On the other side, though, we have to deal with these fractions. So if you multiply by 4/4 here, you get that's 24/4. So it's 9 minus 24/4, which is -15/4. Well, now I have something that I can solve using the square root property. Basically, I take the square root of both sides. Taking the square root on the left side eliminates my square. Taking the square root on the right side, I have to write plus or minus because I am looking for all the solutions to the equation. I am not just looking for the principal square root of -15/4. So I am going to go and say the square is gone there, and over here I can't square root -15, but I can write it as I square roots of 15, and I can square root 4, so that's over 2, and it's plus or minus. When I move the 3/2 to the other side, you can see once again I get 3/2 plus or minus the square root of 15 over 2i. Now, just in case you aren't too good at completing the square, you're not good at figuring out, oh, I need to divide this term in half and then square it. And that's what I add to both sides, and then it factors into x, this sign. Notice here, keep this sign, and this thing here is always that thing divided in half. But let's say you're not good at that. It's too hard. Well, what you can do is you can use the technique we used on number 3 when I told you that anytime you're trying to change a quadratic function, f of x equals ax squared plus bx plus c, into the form a times x minus h squared plus k, whenever you're trying to do that, you know that, let's see, where's my pen? That h always equals -b/2a, the opposite of b over 2a, and k equals c minus ah squared. Well, you can use that here. If you move the 6 over, is this not like a quadratic function, but it's already equal to 0? Yeah, so just take this half over here, and let's convert it into something that says a times x minus h squared plus k. How do we do that? We pull out the b and the a, the b, the c, and we plug them into this formula. So doing so, I'm going to have -3. The opposite of b turns out to be a positive 3 here, over 2 times 1, which is 3/2. So A is equal to 1. H is equal to 3/2. Well, what's K equal to? K is equal to C, which is 6, minus 1 times 3/2 squared, which is 6 minus 9/2, or 9/4, right? Because 3/2 squared is 9 over 4. So we're going to have a 9 over 4 here. And we're going to be subtracting that from 6. So let's call this 24 over 4. So it's 24 minus 9 over 4, which is 15 over 4. But you're like, wait a second, we got negative 15 over 4 last time. Well, we did. But remember, we're converting something that's in this form into this form down here. 1 times x minus 3/2 squared plus 15 over 4 equals 0. Do we need the 1? Not really. So let's get rid of that. But there you go. If you move the 15 over 4 to the other side, you'll have your negative 15 over 4 that you were looking for. And when you take the square root, you will once again get x equals, I keep losing my pen, so small, there. You will once again get 3/2 plus the square root of 15 over 2i, and you should get 3/2 minus the square root of 15 over 2i. So there you go. You have 3 different ways you can do it. If you understand the process of completing the square, you can do that. If you want to use this method with the x minus h, you can do that. But I think most of you will use the quadratic formula because that's what you're most familiar with. But isn't it nice that how we do this thing here is consistent with how we did number 3? We could use that technique again. Alright, I guess that's it for this one. Mr. Roserer signing out. Adios.